So in this video, our goal is to review some things about parallel lines and the angles they create, and hopefully get a better understanding for what goes on around a set of parallel lines. So the first thing I'm going to do is draw two parallel lines, and we denote their parallel by putting these little arrows in them. It's very similar to how you denote congruent segments. You put a dash through it. With parallel lines, if they're parallel, you put these little arrows in there. And then we're going to introduce this red line. And what we call this red line is a transversal. So a transversal is just any line that goes through both of your parallel lines. And then what I'm going to do is I'm going to number our angles just so we can talk about them easier. So 1, 2, 3, 4, 5, 6, 7, 8. And what we're going to do is we're going to identify some trends that happen, some things that we know around these parallel lines. So let's start with an easy one. We're going to start with two easier ones, and then we're going to get into some kind of the more formulaic angle relationships. So the first thing we're going to do is we're going to talk about supplementary angles. And the way I'm kind of format this is we'll name the angle, we'll give an example from our diagram, and then we'll kind of talk about what they are. So supplementary angles add up to 180. They're angles that are along a straight line. So in this diagram, there are many examples, but we could use 1 and 2 if we wanted to. So angle 1 here and angle 2, they're both on this straight line, and they're the only angles there. So they must, if we add the measures of those angles together, we must get 180. So what's the result? We know they are supplementary, right? Sorry, they are supplementary. We know they add up to 180 degrees. All right? So let's talk about another interesting and easier to understand set of angles. Let's talk about vertical angles. And those are going to look like angles 1 and 3, or 5 and 7, 6 and 8. Those angles are formed by two intersecting lines. So we've got this white the line that's parallel to the other one. Then we've got our transversal. And the opposite angles, so here we've got 1 and 3 and 2 and 4. So 2 and 4 are vertical angles, 1 and 3 are vertical angles. And I think it's easy to see that those are going to be congruent. So I'll put a little congruent symbol over here. So those are going to be congruent to each other. So our next angle up is going to be the corresponding angles. So corresponding angles are angles that are on the same, they're both on top or below. So 2 and 6 are both on top of the parallel lines and on the same side of the transversal. So they are corresponding. Now, we could also look at 4 and 8 as corresponding because they're both on the bottom side of the parallel lines and on the same side of the transversal. So those are corresponding angles. And corresponding angles, let's write down, let's do 1 and 5. There's another pair of corresponding angles. And those are going to be as congruent as well. It's a little easier to see. If these lines are parallel and that transversal goes through, it's going to make the same angle here and here because these lines are parallel to each other. So hopefully that makes sense and it's easy to see. So now what we're going to do is we're going to get into the alternate and same side interior and exterior angles. So we're going to define some regions here. So we're going to call this the interior. And what I mean by that is in between the parallel lines. And then we've got two exterior regions, above and below. And we're just going to use that to name some angles. So if it helps, we can continue these lines out. so that we can see more clearly our interior and our exterior. And then when we talk about, we're also going to bring up the alternate and same side when we name these angles. So all we're talking about there is on what side of the transversal these angles are relative to each other. So if they're on the same side, like 1, 4, 5, and 8, those would be same side angles. Or if they're on alternate sides, like say 4 and 6, or 4 and 3, those would be alternate sides of the transversal. So let's start with alternate interior angles. All right, so like the name implies, they're going to be on opposite sides. So alternate, they're on opposite sides of the transversal. And interior means that they have to live in this region in between the parallel lines. So if we look at the angle 4, the alternate interior angle to 4 would be 6. They're both interior angles and on opposite sides of the transversal. The other pair of alternate interior angles that we have are 3 and 5. So let's think about their relationship to each other. Well, let's pick 4. So here's angle 4. And we want to compare it to angle 6. Well, what is the relationship between 4 and 1? Well, 1 is supplementary to 4. Then, if we take that, we know that is also 1 is congruent to 5 because they're corresponding angles. So 4 must be supplementary to 5. And then if 4 is supplementary to 5 and 5 is supplementary to 6, we know that 4 must be congruent to 6. So we'll write down, let's just do 4 and 6 for our example, and we know they are congruent. So alternate interior angles are congruent. Let's do the other alternate pair, alternate exterior. And this one's a fun one now that we know that alternate interior angles are congruent. Well, let's start with the angle 1. So what I'm going to do is I'm going to do a little chain here. So we know that 1 is congruent to 3 because they're vertical angles. We know 3 is congruent to 5 because they are alternate interior angles. And we know 5 is congruent to 7. So if we follow that chain all the way through, 1 congruent to 3, 3 congruent to 5, 5 congruent to 7. That means that 1 is congruent to 7. And 1 and 7 are what we would call alternate exterior angles. So 1 and 7, and they must be congruent. Now we're going to move on to same side, and let's start with interior. So same side interior, those ones, it looks like it sounds, so we could use 4 and 5. So we need to be the interior, and we need to be same side. So same side of the transversal would be 4 and 5, or you could look at 3 and 6. Well, what do we know about these? I don't know if they're going to be congruent, but do we see that? Let's look at this again. 4 is supplementary to 1. 1 is congruent to 5. So you could kind of think about it as we could take 5 and swap it with 1 because they're congruent. So then that shows us that 4 and 5 are supplementary. So they add up to 180. So let's use 4 and 5 as our example. We'll write that down. And we know those add up to 180. So now for our final type, and oh, look at that, I forgot an E. Our final type of angle is going to be same side exterior. Let's do same side exterior. All right, so same side exterior, if we're looking at angle 1, we would need to go same side, and another exterior would be 8. Well, let's figure out what we know about those. Well, we knew when we looked at alternate exterior angles that 1 was congruent to 7 because they're alternate exterior angles. So if 1 is congruent to 7, that would be the same. We could put a 1 down here, and we would see that 1 and 8 are supplementary. So same side exterior angles are going to be supplementary. I'll write down 1 and 8 for our example, and those add up to 180. So hopefully this doesn't seem too complicated. There are a few things to remember, but it's pretty intuitive. So when you are faced with a parallel line problem, make sure you've got a transversal. Remember, this only works when you've got your transversal. It needs to be a solid line through those parallel lines in order for all of these things to work.